Okay, let's take a look at what's happening, right? Is everybody getting some confusing things? Okay, let's take a look at this. So the process, remember, to get to your template for the system solver is you need to go to the custom menu. The custom menu is accessed by this little custom right above home. So second function, home. That changes our tabs. Right? And then we can choose the solver tab. Go down to the template, number 4. And then you can enter your equations directly into this spot. So we have a 4x plus 2y equals 16. And the other equation, be careful, make sure you understand sometimes the terms will switch around. So y plus 2x is equal to 8. Then you can hit solve. Okay, and you see this little @ symbol on your calculator, right? Okay, that @ symbol tells you, if you see that, what it basically means is these are the same equation. Okay? This is, if you were to write each of these in slope-intercept form, they're exactly the same thing. So this bottom equation would be y equals negative 2x plus 8. In this top equation, if you subtracted a 4x from both sides, you get 2y is equal to negative 4x plus 16. Divide by 2, and you get y is equal to negative 2x plus 8. It's the exact same thing. Okay, so when you have two forms of the same equation, two different forms of the same equation in your system, your answer is there's an infinite number of solutions. Now, this doesn't mean that everything works. Okay? What it means is if there's since these points or these two graphs overlap everywhere, any solution that, or any set of points that's a solution to this graph is also going to be a solution to here. So there's an infinite number of solution pairs, or ordered pairs that are solutions. It's not that every single thing works, but the solution or the answer for this type of a problem, anytime you see the @ in your answer, you're going to select infinite solutions. Okay? So these may be mixed in with the others. There may be a set of problems where it specifies, just determine does it have one solution or many solutions or an infinite number of solutions. Okay? Eddie, Andrew?
How are we going to write that on the test? Like, what's the...
You can spell the word infinite.
Okay.
Okay. But it'll most likely be a drop-down. Choose like a matching. Okay. It's either one solution, many or infinite solutions, or no solution. Okay. Eileen, question? Okay. All right, let's take a look at something like this. Okay. I want you to see if you can find the solution to this system. If it has an @ symbol, then you're going to have infinite solutions. What happens now? Again, in your custom menu, choose the solver template for a linear system. Enter your equations. 3x minus y equals 1. And 3x minus y equals negative 2. Hit enter, and it says false. What do you think false means, Eddie? There's no answer. Okay, so if you get a false, what that means is no solution. Okay? The answer of false on a system tells you that these two graphs right here are going to have, they're going to be parallel to each other. So will they ever intersect? No. And again, you can see that if you put each of these in slope-intercept form. In this one, you get 3x minus 1 equals y. In this one, you get 3x plus 2 equals y. So here your slope for both of them, remember the slope is the m part of that slope-intercept form. If the slopes are exactly the same and the y-intercepts are different, then every time this graph moves up 3 over 1, this graph also moves up 3 over 1. So they're never going to start to meet. They're never going to intersect. And so if your calculator shows on the system solver an answer of false, you'll translate that into no solution. Okay, so anything that you see the @ symbol means infinite solutions. When you see false, it means no solution. If you get a specific answer, okay, then it would have one solution. So it's got to be one of those three things. It's either parallel lines, or the same line. Okay, if it's the same line, then you have an infinite number of solutions. Or the system is two lines intersect, and if two straight lines intersect, they can only intersect at that one single point. Okay, so here are the three different cases. Okay, so this just adds to what you have. Everything else, you'll wind up doing the same thing. So if you find a system with one solution, you may be asked to identify it as one solution and then locate what is that solution. If you have an infinite number of solutions and no solution, that's all you'll have to identify. And you won't have to pick anything else.